Students, good morning to all. Now, today's class, we are going to see the remaining numerical problem. Already in the last class, we completed up to the third question. Now, we are going to start at first the fourth question. See the fourth question. Fourth question, a beam of light of wavelength 600 nanometer from a distance source falls on a single slit 1 millimeter wide and the resulting diffraction pattern is observed on a screen 2 meter away. What is the distance between the first dark fringes on either side of the central bright fringe? So we are going to calculate the distance between the first dark fringes on both sides. So in a single slit experiment, the diagram right. See this one. So at this point, it produces the central maximum, and we consider at the point B, it produces a first dark fringes. So the distance between the center maximum and the first dark fringes, I am going to take that value is y or y1. So in this question, we are going to calculate the distance between the point B dash and B. That is the distance between the first dark fringes on both sides from the center bright band. So if you are taking this is y1, this one is y2. We know that the distance between the point O and B dash is equal to the distance between the point O and B. So we can easily calculate the value of y if you know the value of y1, because the y is equal to y1 plus y2. The formula for the single slit experiment is d sine theta is equal to n lambda. D sine theta is equal to n lambda. Lambda is a known value and d is also a known value, but we don't know the value of theta. So by using the diagram, we can easily calculate the value of sine theta. So theta, this distance is nothing but d, and this is the y1. So you are applying the sine theta value for this diagram. If the theta value is very minimum, we can say that the sine theta value is equal to tan theta. So from the diagram, I am going to calculate at first the tan theta. Tan theta is equal to y1 divided by d. For minimum angle, we can take the sine theta is equal to tan theta. So apply all the values. D tan theta is equal to n lambda. For tan theta, we have the value y1 divided by d. D y1 divided by d is equal to n lambda. So in this question, first of all, we are going to calculate the value of y1. y1 is equal to y2. So y1 is equal to d by d n lambda. y1 is equal to d by d n lambda. D given, d given, and lambda given. So we can easily calculate the y1 value. What is the n value? First dark fringes. So we can take the n value is 1. y1 is equal to 2 divided by 1 millimeter 10 power minus 3 for n 1. Lambda value 600 nanometer 6 into 10 power minus 7. So you simplifying this one, 12 into 10 power minus 4 meter. y1 value 12 into 10 power minus 4 meter, or otherwise we can write the value like this, 1.2 millimeter. The y1 value, the first dark fringes appeared from the center maximum 1.2 millimeter apart, and y2 value is also 1.2 millimeter. So y is nothing but y1 plus y2. It is 2.4 millimeter. So the 2.4 millimeter is the distance between the first dark fringes on both sides from the center bright band. Next, the fifth question is also based on the same formula like the fourth question. First, see the fifth question. Fifth one. Light of wavelength of 5000 Armstrong produces diffraction pattern of the single slit of width 2.5 micrometer. What is the maximum order of diffraction possible? For maximum order, the sin theta value is equal to 1. This is also related to single slit experiment. So the formula is same. D sin theta is equal to n lambda. N value we are going to calculate. For maximum, the sin theta value is equal to 1. So D is equal to n lambda. N is equal to D divided by lambda. D value 2.5 micrometer 10 power minus 6 divided by 5 into 10 power minus 7. So this is nothing but 25 divided by 5. 25 divided by 5. So the answer is 5. So the order for the given width of the slit, the order is 5. The 5 is the answer for the fifth question. And next, sixth one. Note the sixth questions are very important. Read the question carefully. I naught is the intensity of the light existing between two cross polarites kept with their axis perpendicular to each other. A third polaroid is introduced between them. What must be the angle between the axis of first and the newly introduced polaroid to get the maximum light for the whole arrangement? So here in this case we are going to use three polarides. If you are consider the polaroid 1 and 2 like this, P1 and P2. This is parallel to each other, but as per our condition, the P1 and P2, these two polarides are perpendicular to each other like this. Now we are going to introduce another one polaroid, third polaroid in between the 1 and 2. So B3. So in this question, we are going to calculate at which angle between the P1 and B3 and B2 and B3, we get the maximum intensity of light from the whole arrangement. The intensity of the light incident on the polaroid P1 is taken as I naught, and the emerging light from the first polaroid, it is I naught by 2. It is always a constant, I naught divided by 2. Now we are going to calculate I double dash. I am taking I dash as the intensity of the light emerging from the polaroid 3, P3, and I double dash is nothing but intensity of the light emerging from the whole arrangement. We don't know the angle between the B1 and B3 and B2 and B3. Initially, I fix the angle between the polaroid P1 and B3 0 degree. So the intensity of the light emerging from the third polaroid here, P1 and B3 is parallel to each other. So here the light intensity is nothing but I naught by 2. So same amount of light it can be emerging from the third polaroid. So here the intensity is nothing but I naught divided by 2. Now the angle between the P3 and B2 is 90 degree, because initially you are given the condition the angle between the first and second polaroid is perpendicular to each other. That means 90 degree. So angle between B3 and B2 is 90 degree. So I double dash is nothing but 0. The light cannot be emerging from the second polaroid. because B3 and B2 mutually perpendicular to each other. So the light is completely stopped by the polaroid B2. So intensity of the light from the whole arrangement is 0. And now next I fix the angle between B1 and B3 is 30 degree. If the angle between B1 and B3 is the 30 degree means the intensity of the light ray is nothing but I naught divided by 2 cos square theta. I naught divided by 2 cos square theta. Here the theta value is 30 degree. So cos 30 degree root 3 by 2. So cos square theta 3 divided by 4. So the final answer is 3 I naught divided by 8. Intensity of the light emerging from the third polaroid is 3 I naught divided by 8. So this is the intensity of the light ray incident on the second polaroid. 3 I naught divided by 8 is the intensity of the light ray incident on the second polaroid. Now the angle between B3 and B2 is 60 degree. This angle 30 degree. So this angle is nothing but 60 degree. So we are going to apply the formula for this case. 3 I naught divided by 8 cos square theta. The theta value 60 degree. Cos 60 degree. One by 2. Cos 60 degree 1 by 2. So cos square theta 1 by 4 3 I naught divided by 32. So the final intensity of the light emerging from the whole arrangement is 3 I naught divided by 32. And next, if you set the angle is 45 degree means here the intensity value is I naught divided by 4. I naught by 2 into cos square theta. Cos 45 degree is 1 by root 2. So I naught by 2. Here the angle between the B3 and B2 is 45 degree. So once again the final intensity I naught divided by 8. If you have said the angle is 60 degree means here the intensity of the light ray is nothing but 8. I naught divided by 8. And here the angle is 30 degree. So the final answer 3 I naught divided by 32. 3 I naught divided by 32. So now you compare all these 4 results. In the third one, out of these 4, in the third arrangement, if you set the angle between B1 and B3 is 45 degree, and also the B3 and B2 is 45 degree, the final intensity of the light ray is I naught divided by 8. This is the maximum one. So the angle between the polarides in each pair is 45 degree. We get the maximum intensity of the light ray from the whole arrangement. And also we can check any of the other angle. If you fix the angle between the B1 and B3 is 40 degree. Here the angle is nothing but 50 degree. So if here the 40 degree means in this place the intensity of the light ray is nothing but I naught divided by 2 and 0.5686. The intensity of the light ray in this case 0.5868. And once again here the angle is 50 degree. So final intensity of the light ray is nothing but I naught divided by 2, 0.2424. The final intensity is nothing but 0.2424. And you compare this value with the third result. Here we get the value I naught divided by 2 into 1 by 4. I naught by 8, it can be written as I naught by 2 into 1 by 4. So this 1 by 4 is nothing but 0.25. So compare with all the arrangement, this is the third arrangement, it gives a more intensity from the whole setup. So the answer is 45 degree. You note this tabular column. It may be helpful to you for our numerical question, 2 more, 3 more, and 1 more question. And next, we are going to move the next question, 7th one. Read the question first. An unpolarized light of intensity 32 watt meter per minus 2 passes through 3 polarites such that the axis of the first and the last polarites are at 90 degree. What is the angle between the axis of first and middle polaroid so that the emerging light has an intensity of only 3 watt meter power minus 2? So the intensity of the incident light in this case I naught is equal to 32 and the final intensity value 3 watt meter power minus 2. So here in this question also we have the 3 polaroid 1, 2 and 3. Now we are going to calculate the angle theta value. Like the same problem, same arrangement, but here they are given the intensity of the incident light and the intensity of the emerging light from the final arrangement, whole arrangement. So now I am going to write the formula for the case I double dash is equal to, if you write the formula for I dash, it is the intensity of the light ray emerging from the middle polaroid. I dash is equal to I naught divided by 2 cos square theta. For I double dash, this is the intensity of the incident light ray for the final polaroid, last polaroid, and additionally we are including the formula cos square theta. Okay, theta is the angle between the first and middle polaroid. This is the angle between the mid polaroid and the last polaroid. So this angle, this is theta. So this angle is nothing but 90 minus theta. Okay, the last class, problem we discussed about the angle between the P1 and P3 is 45 means, and P3 and P2 is also 45 degree. So here theta, in this point we are introducing the another one term 90 minus theta. So now we are going to consolidate this equation. The cos 90 minus theta is nothing but the sin theta. So I naught divided by 2 cos square theta sin square theta. I naught value 32, I double dash value is 3. So you apply the value here 3 in this place 32. So you simplify this one 16. So now I am going to write the formula like this: 4 cos square theta sin square theta. The left hand side we have the term 3. Now we consider this nothing but 2 cos theta sin theta whole square. 3 is equal to 4, 2 cos theta sin theta the whole square. Now I am going to apply the trigonometric relation for this case. 2 cos theta sin theta, it is nothing but sin 2 theta. So 3 by 4 is equal to sin 2 theta the whole square, or otherwise it can be written as sin square 2 theta. Sin square 2 theta. If you take square root on both sides, root 3 divided by 2 is equal to sin 2 theta. Root 3 divided by 2 is equal to sin 2 theta, and we can write the formula 2 theta is equal to sin inverse of root 3 divided by 2. 2 theta is equal to sin inverse of root 3 divided by 2. So this angle root 3 by 2 is the value for which angle in natural sine? Root 3 by 2. There is nothing but 60 degree. This angle is 60 degree. So 2 theta is equal to 60 degree. So theta is equal to 60 degree divided by 2, 30 degree. So in this question, the answer, the angle is 30 degree. 7th question, the final answer is 30 degree. And next question, so the 8th question. The reflected light is found to be plane polarized. When an unpolarized light falls on a denser medium at 60 degree with the normal, find the angle of refraction and the critical angle of incident for total internal reflection in the denser to rarer medium reflection. Now we are going to find out the R value at first, and finally critical angle also we are going to calculate. So angle of incident given I value is equal to 60 degree. We can easily calculate the angle of refraction. The formula for this case R is equal to 90 minus I. I value 60 degree. So angle of refraction 90 minus 60, the answer is 30 degree. R value is 30 degree. And also we are going to calculate the critical angle. For critical angle, we have the formula I N1 sin I is equal to N2 sin R. Here they are given the condition is total internal reflection. The total internal reflection, it takes place only when the light ray is from denser medium to rarer medium. So here the N1 is the refractive index of the denser medium. This one is the refractive index of the rarer medium. Here the rarer medium is air, so N2 value is 1. So N1 is the refractive index of the denser medium. We don't know the value, but we know the value of R. R is equal to 90 degree. At the critical angle, the angle of refraction is 90 degree. So the refracted ray, it traces the surface which is separated to the two media, and I value is also a known value. So first of all, I am going to calculate the N1 value, refractive index of the denser medium, by using the formula Brewster's law, mu is equal to tan IB. Mu is equal to tan IB. IB value 60 degree. So tan 60 is nothing but root 3. Tan 60 is equal to root 3. So now I am going to apply the mu value into the Snell's formula. So root 3 sin IB. This is nothing but now this is a critical angle. So we can write the formula is like this. C is equal to the right hand side totally 1. N2 value 1. Sin 90 degree is also 1. So sin C is equal to 1 by root 3. C, critical angle, is equal to sin inverse of 1 by root 3. Sin inverse of 1 by root 3. And in the normal trigonometric tabular column, we don't know the value for 1 by root 3. So now we are going to use the natural sine. Natural sine value we are going to use. So the 1 by root 3 value in the natural sine, it gives a value 35 degree 9 minutes. So the critical angle is 35 degree 9 minutes. So first you simplify this value 1 by 1.732. You divided this value and you calculate the angle for this value in the natural sine tabular column. The angle, critical angle, is equal to 35 degree 9 minutes. In your textbook, they are converting that 9 minutes into the degree. So this value is approximately equal to 35.15 degree. 35.15 degree, or otherwise 35 degree 9 minutes. This is the answer for this 8th question. R value 30 degree and the critical angle is 35.15 degree. Next 9th question. 9th and 10th question. It is related to the students. This 9th and 10th question is related to optical instruments. The 9th question, they are given the near point and the far point. Near point is 50 centimeter and the far point is 500 centimeter. So first of all, we are going to calculate the focal length, because in this question, 9th question, they are asking to calculate the power. So power and focal length is inversely proportional to each other. So if you want the power of the given lens, first of all we need the value of focal length. So focal length formula, lens formula, 1 by f is equal to 1 by v minus 1 by u. U given and v is a constant value, 25 centimeter. To read a book, that minimum distance 25 centimeter. So u and v is given. So we can easily calculate the f value by using the lens formula. 1 by f is equal to 1 by 25 minus 1 by 50. So take LCM. 2 minus 1 is equal to 1 by 50. 1 by f value 1 by 50. So f is equal to 50 centimeter.
Focal length is equal to 50 centimeter. Power is nothing but P is equal to 1 by F. So is equal to 1 divided by 50 centimeter. You must convert that centimeter into meter first. So 100 divided by 50 is equal to 2. 2 diopter. The power of the lens is the 2 diopter. And next we are going to see the maximum distance. The person can be see the maximum distance up to the particular limit. We are going to calculate that maximum limit. The F value already we calculated. The value is 50 centimeter and U known value. So P only we are going to calculate in the ninth question. So 1 by F. V only we are going to calculate. So 1 by V is equal to 1 by F plus 1 by U. F value 1 by 50 centimeter and the U value is 500. So 500 10 plus 1 by V is equal to 11 divided by 500. 1 by V is equal to 11 divided by 500. So V is equal to 500 divided by 11 is equal to 5 centimeter. So V is equal to 45.45 centimeter. This is the maximum distance for the particular person having the focal length of the lenses is equal to 50 centimeter. So this is the answer for the 9th question. And 10th question is also related to the optical component. Especially this question is related to the compound microscope. Now I read the question first. A compound microscope has a magnifying power of 100. So the M value, magnifying power value 100. And when the image is formed at infinity, so if the image is formed as infinity means it is a normal focusing. We are applying a normal focusing condition. In compound microscope, we study the two different category. One is a normal focusing. So if the image is formed at infinite distance, this is related to the normal focusing case. And the objective has a focal length. F is equal to objective focal length. So FO is equal to 0.5 centimeter. F naught value 0.5 centimeter. And the tube length is 6.5 centimeter. Tube length L is equal to 6.5 centimeter. And what is the focal length of the eyepiece? Focal length of the eyepiece FE. So magnification given, F naught given, the L is given, and FE we are going to calculate. The magnification formula for the compound microscope is M is equal to M naught ME. M is equal to M naught ME, and M naught value and ME value they are not given. They are given the value of F naught L and M value. So we are going to apply the another one formula L divided by F naught D divided by FE. For F naught M naught L divided by F naught. For ME D divided by FE. So here the ME value, we have the two value. One is 1 plus D by FE, another one is D by FE. This ME value is equal to D by FE for the case of normal focusing. Okay, if the image is formed at infinite distance, we can use the M is equal to D by FE. If the image is formed at the near point, the formula for ME is 1 plus D by FE. So now we are going to calculate the value of FE. So now I rearrange the formula. FE is equal to LD divided by F naught M. L value, F naught value, M value given. D is nothing but 25 centimeter. D is at 25 centimeter. So we can apply all the values in the given formula. F is equal to L value 6.5 centimeter and D value 25 centimeter divided by F naught value 0.5 centimeter and M value 100. So simplify it 4 times 2. 6.5 divided by 2. So the answer is 3.5 3.25 centimeter. So the Fe value is equal to 3.25 centimeter. The condition is the image is formed at an infinite distance, means there is a normal focusing. So you concentrate this part. Infinite distance, there is a normal focusing method. So ME value is d by Fe. If suppose the image is formed at the near point, means M value is 1 plus d by Fe. We get any separate answer for Fe. This is related to the 10th question. So now we are going to discuss some of the additional questions related to the polarization concept. Okay. The first question, which of the following waves can be polarized? Which of the following waves can be polarized? X-rays, sound waves, give reason. Which of the following waves can be polarized? We know that the transverse wave nature, it is explained with the help of polarization phenomena. So they are given the two different type of the waves. One is X-rays and other one is sound waves. X-ray is one of the electromagnetic wave and it has a transverse nature. So X-ray is the answer for this question. The reason is it is an electromagnetic wave, one of the electromagnetic wave. And the second question, two polaroids P1 and P2 are placed parallel to each other, then B2 is rotated through an angle 45 degree, 90 degree, 180 degree. The rotation 45 degree, 90 degree and 180 degree. How would the intensity of the light coming out of B2 be affected for this angle of rotation as compared to the initial intensity? So we have the two polaroids P1 and P2. Initially we kept the two polaroids in the same axis and parallel to each other. So the angle between the polaroids P1 and P2 0 degree. If we consider I naught is the intensity of the incident light ray on the polaroid P1. So the light emerging from the polaroid P1, it has the intensity value I naught divided by 2. I naught by 2 is the incident light intensity for the second polaroid B2. And the emerging light ray from the polaroid 2, it is named as I dash. I dash is equal to I naught divided by 2 cos square theta. I naught divided by 2 cos square theta. So we are going to apply the theta value for three different cases, 45 degree first, 90 degree and 180 degree. If we rotate the P2 second polaroid 45 degree from the initial position, it is rotated through the 45 degree. So now the theta angle between the polaroid 1 and 2 is 45 degree. So in this place you apply the cos 45 degree. The cos 45 degree value 1 by root 2. So final intensity 1 by root 2 square. So final intensity I naught by 4. This is related to the 45 degree. If you turn the second polaroid up to 90 degree, so P1 and P2 is mutually perpendicular to each other. There is no emerging light from the second polaroid. So intensity for the second case, intensity of the light ray and the whole arrangement is equal to 0. For the first case, 45 degree rotation, I naught divided by 4. It is reduces by 1/4. And third case, 180 degree, it is rotated to 180 degree. 180 degree, it is once again parallel to the first polarized. 90 degree it is perpendicular. 180 degree means it completes the half circle. So once again the P1 and P2 is parallel to each other. So the value for theta is equal to 0 degree and the same value for the theta is equal to 180 degree. For theta is equal to 0 degree, the intensity is I naught divided by 2 and 180 degree is also the intensity is I naught divided by 2. Parallel 0 degree means I naught divided by 2. There is no change in intensity of the light ray from the first polarized and second polarized. I naught divided by 2 because cos 0 value is 1, so 0 1 0. I naught divided by 2. Here I naught divided by 2. Here also I naught divided by 2. If 45 degree means here I naught divided by 2 and the final intensity of the light ray is I naught divided by 4. And the 90 degree means from the first polarized I naught divided by 2, from the second polarized is 0. For 180 degree from the first polarized I naught divided by 2 and the second polarized it emit the emerging the light ray with the intensity I naught divided by 2. Okay, so second one. And next question. Same concept. Two polarized easily we get the two polarized parallel to each other. Now I am going to rotate the first polarized. Rotate the first polarized in between 0 degree and 90 degree. Calculate the variation of intensity of the light transmitted by the first polarized. We fix the second polarized. Initially the polarized P1 and P2 is parallel to each other. Now I am going to rotate the first polarized between 0 degree and 90 degree with respect to the second polarized. So if you rotate that polarized P1 from 0 to 90 degree, what will be happen? That means the transmitted intensity, variation of the transmitted intensity from the first polarized. The variation of intensity from the first polarized is equal to 0 because there is no intensity variation produced when the incident light ray is falls on the first polarized and the rotation is applied in the same polarized. The light is falls on the first polarized and we are going to apply the angle variation for the same polarized means there is no intensity variation produced for the transmitted light from the first polarized. So I variation is equal to 0. The last one we are going to give the graphical representation for the intensity variation. Here in this case the light from an ordinary source is passed through a polarized sheet P1. The transmitted light is then made to pass through a second polarized sheet P2, which can be rotated so that the angle between the two polarized sheets varies from 0 degree to 90 degree. So the graphical representation for the variation of the intensity of light transmitted by first polarized and the second polarized. So we are going to draw the graph with respect to intensity and the angle. Initially I am going to draw the graph for the intensity of the light transmitted by P1. In x-axis theta angle variation, in y-axis intensity of the light ray. I is the intensity of the incident light ray. Here we have the two polarized P1 and P2. Initially, two polarized are parallel to each other. The I intensity, the light falls on the polarized P1, and the intensity I. And the transmitted light have the intensity I naught divided by 2. If you take I naught, then I naught divided by 2. Okay, and here it is emitted like this I naught divided by 2. Now, the initial angle between B1 and B2 is 0 degree. So, you take this origin 0 degree means you fix any one of the value. Now, I consider this point, it has a value I0 divided by 2. If you rotate the Polaroid P1 in between the angle 0 degree to 90 degree. So, maximum value 90 degree. Already I told that if the light ray is incident on the particular Polaroid and also you are going to apply the angle variation for the same Polaroid means there is no change in intensity for the transmitted light by the particular Polaroid. So intensity does not change. So we can draw a straight line from the value I0 divided by 2. If the angle between P1 and P2 is 0 degree, it emits the light ray, it has intensity I0 divided by 2. Up to the variation of 90 degree, there is no change in intensity of the light ray transmitted by the first Polaroid. If you are applying the rotation for the first Polaroid. This is the respect to the Polaroid one. Now I am going to turn the second Polaroid. Now I fix the Polaroid one in a particular position. I am going to change the angle between B1 and B2 by changing the rotation for the second Polaroid. Second Polaroid, I am going to rotate the second Polaroid. So now already we know that the intensity variation I is equal to I0 divided by 2 cos by theta. The intensity is varies whenever you are going to rotate the second Polaroid and the first Polaroid is a fixed one. It varies with respect to the formula I is equal to I0 divided by 2 cos square theta. So initially we consider the theta is equal to 0, parallel. The two polarities are parallel to each other. So intensity, maximum intensity, it is produced at the angle 0 degree, I0 divided by 2. Now if you rotate it from 0 degree to 90 degree, 90 degree means the Polaroid 1 and 2 is mutually perpendicular to each other. So the emerging light from the second Polaroid is 0. If the Polaroid P1 and P2 is perpendicular to each other, then there is no light rays emerging from the second Polaroid. So intensity is completely 0 at the angle 90 degree. So definitely this decreases like this. Gradually the value decreases. At 45 degree, you can write 45 degree. The value is nothing but I0 divided by 4. I0 divided by 4 at 45 degree. 0 degree I0 divided by 2, 45 degree I0 divided by 4 and 90 degree it is the 0 value for the intensity of the emerging light ray from the second Polaroid. So you note that graphical representation with respect to the two cases whenever you are rotating first Polaroid and if you rotate the second Polaroid. We can apply the same concept by using the 3 polarites or 4 polarites. Okay, so you first understand the concept. This is very important for a numerical question. Polarize and interference and diffraction question also very important. So students, in this class I completed the numerical problem, the 7th chapter. From next class we are going to start the new chapter, Unit 8, Dual Nature of the Light. We will meet in the next class. Thank you students. Thank you.